Hello everybody, welcome to today's lesson. We're going to talk about section 9.5, part 1 today, part 2 next time. We're going to talk about a matrix and something called the determinant of a matrix and how it can help us solve a classic type of math problem. So let's go ahead and start. Now today all we're going to do is discuss briefly what a matrix is and talk about how to find what we call the determinant of it. And then in part 2 next time, we'll actually solve the problem using what we learned today. All right, first of all, in math, a matrix is just a way to organize data. It's just a way to organize data that you collect. It looks like numbers inside these types of brackets, okay? And by the way, the plural of matrix is matrices. Okay. Now, every matrix has a size. And the size of a matrix depends on the rows and the columns. It's the number of rows by the number of columns. So let's say we had 4 pieces of data. Let's say we had 4 numbers and we wanted to organize them somehow. We could put it in what we call a matrix that has 2 rows and 2 columns, let's say. Okay? So let's just throw numbers in here. 4, 2, 3. Let's have a negative number, -7. Okay, so this is a matrix, and you have 2 rows and 2 columns. So since it has 2 rows and 2 columns of numbers, it is a 2 by 2 in size, okay? You could have a matrix of any size, really. It just depends on how many pieces of data and how you want to organize it. Now, all of our matrices that we deal with in parts 1 and 2 are going to be 2 by 2 matrices, okay? Because that will be the size we need to solve the type of math problem we do in part 2. Okay, now, here is the formula we're going to use to find what we call the determinant of a 2 by 2 matrix. A times D minus B times C, okay? So these 4 letters or variables stand for the 4 numbers in the matrix. And in the 2 by 2 matrix, A and B are the numbers up top, and C and D are the numbers on the bottom. Okay? So all you do to get the determinant is multiply the numbers in the A and D spots, these 2 spots here, take their product, and then you subtract the product of the numbers in the B and C spots. That's all you do. Okay? So, in this matrix right here, the determinant, which we'll call lowercase d, is simply 4 times -7, because those are the numbers in the A and D spots, minus 2 times 3, because those are the numbers in the B and C spots. And then you just evaluate this, figure out what it is. So you get -28 minus 6, that is -34, which is your determinant value. So you always get a final number when you have the determinant. Sometimes it's negative, like in this case. It could be positive, it could be 0. It just depends, okay? Now, another thing that we'll do in this part 1, rather than just simply take a 2 by 2 matrix and get the determinant, is to take a system of equations like this, and we're going to find the determinant of the XY coefficients, not the coordinates like the note sheet says, but the coefficients, okay? Because this might look familiar to some of you guys. You might have bad flashbacks in algebra over it. when you solve a system, there's many ways to solve it, okay? In algebra, they usually teach you can graph it and look for where the lines intersect. You can do elimination method or substitution method. They usually don't teach this method in algebra classes, but that's what we're going to learn in part 2. So what we're going to practice here in part 1 is to practice taking the determinant of the x and y coefficients. So remember, the coefficients are the numbers in front of the variables that you're multiplying by. So all you do, don't worry about these numbers today. Those are your constants, not your coefficients. But 2, -3, 4, and 8. Okay? Those are your coefficients. So if you put them in a matrix, and then you would find the determinant of it just like we did up here. So 2 times 8 is 16. That's your A and D. Minus, now be careful because you get a negative here. B times C is 4 times -3. That's a -12. Sometimes you have to subtract a negative. Be careful with your negatives and minuses, guys, when you do the determinant. So this is really 16 plus 12, and you get positive 28. All right, so that's what we're doing in part 1, finding the determinant of not only just a regular 2x2 matrix, but also of xy coefficients from a system. Okay, let's try one more example of each, because this is what your homework problems are going to be exactly like. You're going to do this on your homework problems. I adjusted some of the directions on focus, so make sure you pay attention to that. All right, the first type of problem in this section is what we did above. Just take a 2x2 matrix, find the determinant. So nice and easy. A times D, so -18 times -2, and then subtract B times C, -4 times 6. Now, this gives you positive 36, and this is -24, and you're subtracting -24, so this is really like 36 plus 24, and you're getting what, 50? No, 60. So that's your determinant, okay? And the second type of problem you're going to get, and don't follow the book directions. I tell you on focus to only get the xy, use the xy coefficients and get the determinants. That's all I want you to do in part 1 today. So, -6 and 4. Now remember, when there's no number, it's really a 1. So +1, +3. Remember, minuses are like negatives for the coefficients, okay? Pluses are like positives. Don't worry about the constants today. We'll deal with those in part 2 next week. All right, so just like we did above, you don't have to rewrite it as a matrix if you don't want. You can just leave it like this. So A times D, -6 times 3. And then subtract B times C, 4 times 1. So -18 minus 4. And there you go. Determinant of -22. All right, so that's all I want you to do in part 1 today is get the determinant of either a regular matrix, 2x2 matrix, or get the determinant of the xy coefficients of a system of equations. That's it. All right, guys. Thanks for listening, and I will talk to you next time. Bye-bye.